we have two sides of the classroom. We got this side and this side. You guys will work in a group. You guys will work on the group. Go through all of the questions here. I have the handout here. Answer these. If you see the name, then write the formula. If you see the formula, then write the name. There are totally 11 questions on there. I'm going to have you go up, since there's 5 people in the group here, and there'll be 5 people. You guys are going to work as a group. You're going to send one person up to put the answers up here with the stylus up here. So one person's not going to go up and write everyone up. So each one's going to write one answer. You guys are going to be responsible for doing the odd numbered ones up on the board. You guys will be responsible for putting the even ones up. So odds and evens for 1 through 10. So pick out one person to send up one problem. So you guys are the odds, you're the evens. We're going to keep score to see which side does best. And then if you're tied here 5-5 or 4-4 at the end, then we'll have numbers 11 and 12 be your tiebreakers to see who wins. And you might say 11 and 12. Well, that's because I forgot to put number 12 up there. Here's number 12. If you want to do this, 11 and 12 are the tiebreakers. So get in your groups. You guys are responsible for doing the odds. You guys will do the evens for 1 through 10. Designate one person to go up with a particular one. So our volunteer, say I'm going to go 2, I'll do 6, I'll do 3. But check your answers. And when you write with the stylus, there's a button on here. If you press the button, when you write, it's going to do all sorts of funny things on here. So just avoid pressing the button when you hold the stylus. All right, go. If anybody wants to come up and put theirs up right now, remember each person has to come up here at least once. I have my stylus. Which one are you doing there, Mike?
Number 2.
Number 2? All right. Just be careful on the button there. Don't press the button or it's likes to go all over the screen.
Okay.
And I do make it look a lot easier to write on this thing. And
I think so. I don't know.
yeah. Comes with practice. Which one you got?
8.
8? Well, can you move it down? I don't see the bar.
Oh, I don't either. Here, you can.
Okay. There it is.
Okay.
So just don't press the button on the.
Ooh, yeah, you do.
Don't forget the Roman numeral.
Oh, same has a charge. Yeah.
Yeah, oh yeah, it has a +2.
I know, they're the same.
Which one you got?
Yeah.
All right, you're in good shape.
Wait a minute, do we all agree on 4? That's what I got.
Yep, that's what I got.
it just a bit.
Then I'm number 4.
You're number 4?
Yeah.
Here, I need this. There you go. Just don't hit that button there. It likes to go all over the place. I don't think these guys have bad penmanship. It takes a little skill here to learn how to write with this thing.
Excuses.
You'll see when your turn comes. Be careful on the button. Which one do you have?
10.
10. Oh, I need this. Okay. You guys have figured out who's doing which ones? All right.
I'll do the first one. How about that? I'll do the first one.
One, two, 5, 7.
Remember, 11 and 12 are bonus, so we're only doing 1 through 9. Okay. Send your ambassadors up. Who's doing which ones? Don't put yours in red. Which one are you?
I'll do the first one.
All right.
You
Just be careful of the button. Don't touch the
Not
button.
touching her.
Well, you can touch it. It just likes to go all over the place.
For 9, you got this right. 9 and 3, so.
Okay, who's doing which one? Your number
I'm doing 7.
7. All right. Just don't touch the button on there.
Where's the button?
Right
Oh.
there.
Okay.
Likes to go all over the place when you do.
Oh, that is really hard to write.
The first day I used this, I was given the tablet right before class. Because my old one died, and this is a different type of stylus, and I mean, stuff was flying all over the screen. All right, which one are you?
9.
9. All right, there you go. Yeah, don't touch the button. And which one are you? 5. You're in enough room, but you're probably 3 in, so. They were making excuses, weren't they?
My handwriting's bad without that.
Yeah, just don't touch the button. No, 11 is the bonus one. The 11 and 12 go on that card there. That's the tiebreaker. All right, let's go ahead. Thanks, guys. All right, so let's go and look at these, and we'll zoom out and see, first of all, if there's any that anybody wants to steal. If they see a wrong answer up there, I'll give you a chance. We'll put any crossouts in black. So check, if you were at evens, you guys do look at the odds. If there's odds, look at the evens. Oh, I do see one correction that somebody could, you have to look very closely to catch it. But there's one error up there. Anybody see the one error? And if you do, I'll give you the stylus.
Wait, is it in the odds or is it?
I'm not telling you which one it is. Because I don't even remember whose is whose. Okay, we're going to give you 30 seconds here to find it. There's one error up there. Make sure you check your own teams too. going to count down here. 5, 4, 3, 2, 1. Nobody sees the error. Okay, well now one team will have won on this. I will give you a hint. It's a spelling error. Which one?
The M.
The end one?
That
Number 2?
That M.
That's a capital M. I'd be gracious to whoever wrote that one in.
Oh, wait, is that O?
No.
Oh, okay.
Anybody find the spelling error?
Oh, yes, I did.
Where is it?
Phosphorus.
And how is it spelled?
Phosphorus.
Correct. Right there, phosphorus. And that's a tough one. That's a real tough one to catch, because when we talk about acids, we talk about the OUS suffix and everything. But the element phosphorus has the US, and it's a real easy one. Now, exam time, here's what I do. That's not a complete total wrong answer. This would be like, if this is a 3-point problem, this would be like a -1 of 3, because it's pronounced the same either way. So if it's a sounds like, you get it correct. I don't give full credit, but I'll give partial credit on it. If it's something though where it's not a sounds like, so for example, I've had students refer to bromine as bromium, that would be a total incorrect one, because that's not a sound like, that's a different sounds like. So that means let's see, that was an even, so that means that the odds won it. Who's the odds? Just so I remember, odds. All right, you guys win. But with that said, let's go ahead and look at the last two here. We don't need the tiebreaker, but what is SO3? You guys have that? What do you have?
Sulfite.
And what did you guys have for it? What do you have?
For number 11.
Number 11.
Yeah, sulfite.
Sulfite. Well, see, that one wouldn't have won it for you because both of you were wrong on this one. The correct answer on this one is not sulfite. This one here is sulfur trioxide. So why is it not sulfite? Why is it not sulfite?
There's not a charge visible.
Right, there's not a charge. This is a compound. It's not a polyatomic ion. So that is one thing that catches, and this is not what you'd call a trick question. This is a real one here. And I would put this on a test just like I put it on here so you know your rules. This is the sulfate ion, which is SO4 with a 2 negative charge, which means that the sulfite ion would be SO3 with a 2 negative charge. This is a compound. Sulfite can be a part of a compound. Earlier today, I think we saw on the Socrative app, I think we saw this one here, K2SO3. K2SO3 would be called potassium sulfite. But when we simply see SO3 and there's no charge, that's telling us that it is a binary molecular compound. As a binary molecular compound, it's a non-metal to a non-metal. First element retains its name. The second element retains its root name, onto which we add an IDE suffix. And then we add the prefix tri to it. So this is sulfur trioxide, which, by the way, is one of the biggest components of acid rain. It comes from burning coal that has high contents of sulfur in it. So this one to solve the tiebreaker, had there been one. The next one, I don't want to shout out the answers. Let's see if you have an answer for the last one. Do you have an answer for the last one here? You didn't do one? Do you have one? You have the tiebreaker. They are correct. The correct answer is?
Cocoa.
Cocoa Puffs. All right. I know. But these guys at least have a night job with me. So, all right. Cocoa Puffs. Any questions on your nomenclature? Any question on your nomenclature? All right. So this takes us on to chapter 6. As I mentioned last week, you're going to be covering most of chapter 6 on your own before class next week. I'm going to give this short introduction here to chapter 6 today to kind of get you on the road. And let's see what we have for chapter 6. All right, chapter 6. Where's my, I'll just put it way at the very end. Chapter 6 is all about counting atoms. Chapter 6 is on counting atoms. And when we count atoms, we're going to use a word that we refer to as the mole to help us count atoms. But before we talk about what the mole is, let's go back to some other words that stand for a specific quantity of items. If we have a dozen of something, that means we have how many? 12. If we have a pair of something, that means we have how many? 2. Right, so we have 2 items. If we have a gross, that means we have? This is where I like to just impress everyone. Anybody know how much a gross is? This is 144. There's actually only one thing I know that comes by the gross, and that's bottle rockets. Okay, so, but a gross is also a dozen, if you need to know. But if we have a mole of something, this is how many items we have. We have 6.022 times 10 to the 23rd items. And we use the mole just like we use a dozen or the gross. And this is kind of like we call the mole the chemist dozen. And this also has another name. We refer to this number as being Avogadro's number. And it's named in honor of Amadeo Avogadro, who had first described measuring quantities of atoms. Now, before we go on and work with the mole a little bit, I want to get some idea of how much you might know about the mole and give an idea how big it is. So I have a question for you here on the Socrative app. So if you can sign in on this here. If we talk about 6.022 times 10 to the 23rd, if we had this number, that is if we had Avogadro's number of ping pong balls. A ping pong ball is about the size of a golf ball. If we had Avogadro's number of ping pong balls, what is your best guess as to the amount of space taken up by this number of ping pong balls? I forgot, who won again? You guys did? All right, I'm sorry, guys. I'm sorry. Huh? Oh, no, that was a spelling error. All right. All right, tiebreaker had to count for something. You guys are here, right? Maybe I'll be generous. Maybe we'll give you some points for everybody here today. How does that sound? Does that work? Is that like a bad rule? Are you going to feel really offended? Okay. All right, I'll give you a point for everyone here today. Okay, so what is your best guess of the space taken up by 6.022 times 10 to the 23rd ping pong balls? Correct answer on this is the entire surface of the Earth to a depth of 60 miles. And when we look at this, it's really kind of hard to believe, but here's one way for you to think about it. And when we start thinking about powers of 10, it's really easy to lose sight as to how things work. So if we talk about, say, something being 10 feet deep, 10 feet deep would be like from here to the ceiling. And that'd be 10 to the first power. If we go to 10 to the second power, that then becomes 100 feet. 100 feet would be probably about the length of 2 classrooms here. So that'd be 10 to the second. If we go to 10 to the third, we're now at 1,000 feet, and we wind up being taller than any building in the city of Minneapolis. And if we get up to 10 to the fourth power, then we're at 10,000 feet, and we're now at a distance of 2 miles. And that's just at 10 to the fourth. And so if we go to there, to 100,000 feet, we now have 20 miles, and that'd be like driving from here to downtown Minneapolis. And so you can see when we start adding on, no, 100? I think I said that wrong. No, that's right, 100,000 feet. So we start looking at those distances, and once you start adding on those powers of 10, they get so large that it's beyond what most of us can comprehend. And so again, if we have this number of ping pong balls, that's going to cover the entire Earth 60 miles deep with ping pong balls. So of course, if we have a really, really big number, and then we know that atoms are really, really small, because we said we use it to count atoms, then the next question is, do you think we can put 1 mole of anything in this room? That is 1 mole of atoms. Do you think 1 mole of atoms is going to fit in this room? And it does. It turns out that that's because atoms are really, really tiny. We're going to write down some facts here for this. Right here I have 1 mole of aluminum atoms. 1 mole of aluminum atoms. And when we write out the mole, we abbreviate it as MOL. So in here I have 1 mole of aluminum. And this is how we write it. We leave off the letter E. Don't ask me why we abbreviate it that way. I don't know. But 1 mole of aluminum has a mass of 26.98 grams of aluminum. And it contains 6.022 times 10 to the 23rd atoms of aluminum. And I go to the next one here. This one here, I have 1 mole of copper. So I write it like this, 1 mole Cu. This has a mass of 63.55 grams of copper. How many atoms would this be in here? All right, 6.022 times 10 to the 23rd atoms of copper. So here's my aluminum, here's my copper. In this one I have 1 mole of lead. 1 mole of lead. Now in this 1 mole of lead, let's see if you can figure out what the mass of 1 mole of lead is. So talk with the neighbor. If you don't know where I got those first 2 numbers, talk with the neighbor. See if you can figure out where those numbers came from, and then put in your answer. This is 1 mole of lead. One mole. What answer are we going to put in? And you do need to put in the correct units here. So you need to know what the units are of mass. We'll let a couple more people register their answers here. Get a couple more answers locked in, please. All right, we'll count down. 5, 4, 3, 2, 1. Correct answer is 207.2 with the units of grams. And where did the people get the answer of 207.2? Periodic table, exactly. So if you didn't know, now you're being told. If we look at these, the first 2 we had was aluminum at 26.98. Then we had copper at 63.55. Now we have lead at 207.2. So if we take those atomic masses and we express them in units of grams, then we have 1 mole of that substance. And how many atoms would there be in that amount? Right, and see that number doesn't change. So there's 6.022 times 10 to the 23rd, or Avogadro's number of atoms contained in 1 mole. And again, this number right here comes from the atomic mass expressed in units of grams. And we refer to this quantity right here, these quantities, we refer to them as being the molar mass. The molar mass. And the molar mass is equal to the atomic weight of the element expressed in units of grams. And we want to make sure that we make a distinction between them, because these here are the molar masses. If we talked about the atomic mass, what is the atomic mass of aluminum? It's 26.98 with the label of AMUs. Atomic mass of copper is 63.55 AMUs. The atomic mass of lead is 207.2 AMUs. So we want to make sure that we have the distinction between the atomic mass and the molar mass. The atomic mass is the average mass of each atom of that element. The molar mass is the mass of 1 mole of that element. So when we want to think of it another way, if we think about the word mole, this comes from a Latin word which stands for heap or pile. So it means we have a whole big heap or a whole big pile of these atoms. Okay, next up. Any questions on those? All right, next up here I have some water and some methanol. In the water I have 1 mole of H2O. In my 1 mole of H2O, we have 18.02 grams of H2O. And this contains 6.022 times 10 to the 23rd. The label on this now is not atoms, but it is molecules of H2O. This is 1 mole of water right here. This here is 1 mole of methanol. And methanol has a formula of CH3OH. And it has a mass of 32.04 grams. And it contains 6.022 times 10 to the 23rd molecules of CH3OH. CH3OH. There we go. Now, I'm not telling you how we arrive at that, but I have 2 other substances here. I have some sugar and some salt. The sugar that I have is sucrose sugar, and the salt, of course, is one that you're familiar with. By the way, we also refer to these right here as being the molar mass. The molar mass. So now the sugar and salt, let's write down these formulas. There's 1 mole of sugar. Anybody know the, and this is sucrose sugar, not glucose. Anybody know the formula for sucrose? It's C12. 22O11. It's going to have a mass of how many grams of C12H22O11? And it's going to contain 6.022 times 10 to the 23rd something or others. We're going to put another word here of C12H22O11. And we also have up here 1 mole of salt. 1 mole of salt. Now what is the formula of salt? NaCl. Now from your vantage point, one of these is salt and one of these is sugar. I have 1 mole of each in here. Which one is sugar and which one is salt? This one here would be salt. This one's salt, and how do we know it's salt? Well, if we look at 1 mole of NaCl, there's not many atoms in the formula of NaCl. There's a whole bunch of atoms in the C12H22O11. See if you can figure out how many grams are in 1 mole of each. And this contains 6.022 times 10 to the 23rd something or other of NaCl. So fill in these masses and fill in these words. And these are going to be the next 3 questions on the Socrative app. You want to know what is the molar mass of NaCl? Give your answer with the correct units. I'm going to try to squeeze these down here just a bit. In for the first one on the Socrative app. We'll check out the answers here on the NaCl. This one's the easier one. We'll count down 5, 4, 3, 2, 1. Correct answer here is 58.44. And how do we get the 58.44 for those that have it? Yeah, Simon?
I just took Na, like to the, just because it's just a 22.99 for the atomic mass.
Okay, yeah.
And then I added it to Cl, which was 35.45.
Exactly. So you took 1 sodium and 1 chlorine, 1 sodium again at 22.99. You had your 1 chlorine at 35.45. You sum these together, you get 58.44. And so that label on there is 58.44 grams of the NaCl. So if you go on to the next one, and we want to put in the molar mass of C12H22O11. I didn't specify significant figures. You can put in 4 significant figures for your answer. Put in 4. And we'll need a couple more here to lock in your answers, please. So we'll count down on this one. We'll count down 5, 4, 3, 2, 1. Correct answer on this one is 342.3. 342.3. In this one, of course, you needed to go ahead and sum together your atomic masses once again. So we have 22 hydrogens at 1.008, 11 oxygens at 16.00. I think if you sum these all the way across, 144.12, this is going to be 22 point something out here. This is going to be 176.00. And summing them together, whatever this number is up here, you're going to wind up 342.3. And so that's 342.3 grams. Then when it comes to the label, let's see what label we need. For this one here, if we want the correct label for the answer here, is this going to be atoms, molecules, formula units, or ions? And the correct answer on this one, counting down, 5, 4, 3, 2, 1. Correct answer on this one here is molecules. And this one here is a label of molecules because this here is a molecular compound. And what is our evidence that this here is a molecular compound? The only types of elements here are nonmetals. So if we have nonmetals to nonmetals, it's comprised of molecules. For sodium chloride, and this is where we're going to wrap up here today, there's no such thing as a molecule of an ionic compound. Sodium chloride is an ionic compound. Now we write a formula of NaCl. It isn't because we have one sodium or one chlorine. In this model here, the small spheres are sodiums, the large spheres represent chlorine. And so where we might take out a water molecule, and with the water molecule, we might write a formula of H2O that represents 2 hydrogen atoms and 1 oxygen atom in a molecule. We don't have that same thing for sodium chloride. In sodium chloride, or in any ionic compound, we have alternating positive and negative ions. And so when we write a formula for sodium chloride as NaCl, that formula is what we call an empirical formula and tells us the ratio of atoms. So if you went through here and counted the small spheres and the large spheres, what you find is that there's a 1-to-1 ratio of sodium atoms to chlorine atoms. And because there's no such thing as molecules in here, we want to refer to them as being something that's like a molecule. The term that we wind up using is formula unit. And so for ionic compounds, we use the term formula units, and we say that this contains 6.022 times 10 to the 23rd formula units. And one formula unit of NaCl is going to contain 1 sodium and 1 chlorine. So that's the introduction here to Chapter 6. Again, read most of Chapter 6 on your own. We are going to start next week with a group activity where we will be doing some problems from Chapter 6. So you need to read that on your own coming in here next week. And I will put in the D2L, make a post and send out an email specifically what those sections are. Okay, that's it.